Okay, grade 12. So here is our third and final example from the forces and equilibrium notes for our dynamics unit. So this should be part 3 of our kind of introduction to dynamics and what it's going to look like this semester. So this is our most challenging example yet. I will explain why it's challenging because we are actually going to have to make our first use of a substitution. So a stoplight is hanging from 2 wires as shown below. The mass of the sign is 30 kilograms. What is the tension in each wire? And I actually want to make a slight adjustment to the question here. This actually should say what is the magnitude? What is the magnitude of the tension in each wire? So I'm not super concerned with the direction. We're just going to find the magnitude. We've already been given the direction, right? The direction's already been given to us. So let's just find what the actual magnitude of that tension in each wire is. So here is our drawing. For those of us that can't see it very well, this is a 45 here. And this is a 37 here. And this we'll call T1, and this we'll call T2. And remember, the direction always faces away from whatever it was pulling on it. Now we've got a gravitational force acting downwards on the object, and we can just, again, like we'd regularly do, let's make some positive and negative directions for when we plug in our scalar values, we can put in the proper sign. So what other information has been given to us in the question? Well, we know that mass is equal to 30 kilograms. We know that G is 9.8 meters per second squared down. And we've been asked to find T1 and T2. I think the best way to go about doing this is just to draw out our scenario again here, like we did on the last lesson. Just make it a little bit more zoomed in so we can kind of see exactly what's going on. So this is T1. This is T2. And we've got T1Y, right, in the Y direction. Remember, always tip to tail, so going from where it starts to where it ends. This is T1X. And this is going to be T2Y and T2X. So there are two triangles now, and we've got, remember, we've got these angles. This is some more information given to us, 45, 37. Okay, at the very least, this is as much as we can do to, if we're confused, just try to get ourselves started. Try to really picture what's going on here now. Now, why don't we write out what all of our components are actually going to be once we plug them into our SOHCAHTOA. So T1X is adjacent to 45, so it's going to be T1 cos of 45 degrees. And T1Y is T1 sine of 45 degrees. Same thing for over here, T2X is equal to T2 cos of 37 degrees, and T2Y is equal to T2 sine of 37 degrees. Now, unfortunately, we can't really go any further than that because we don't know T1, we don't know T2, and we don't know any of the other values here. What we do know is FG though, and FG is going to help us to being able to solve this. Now, when we have a scenario like this where we have a whole bunch of unknown information, chances are that we're going to have to do some sort of working around, figure out how to rearrange some of these formulas to actually give us something useful. So in this case, what the key ends up actually being is that we want to start solving the x direction, and we'll hit a little bit of a dead end. But if we kind of just take a look at the y direction at the same time, we'll see where there will be a moment of clarity where we can kind of take the information that we've solved for in the x direction, plug it in over here in the y direction, and that'll give us a very solvable formula. So let's write down very basically what is going on in the x direction. We've got F net x is equal to 0. Okay, well, what are the forces that are acting in the x direction? It's actually just T1x and T2x, right? So T1x plus T2x equals 0. Okay. Now, let's do something here that we haven't really done before, but I think it should make sense when I do it. I think because generally we've been able to plug in numbers. So if I was going to plug in a number here for T1x, well, that's in the negative direction, right? So let's get rid of these vector arrows, but let's replace T1x with its negative number. So this is technically a negative T1x. It's going to be some sort of negative number. Say it's negative 120, say it's negative 4, say it's negative 3,000, okay? That's what I've done there. Now T2x is in the positive direction, so we'll keep that one positive. And the reason why I did that is because what I want you to realize is that if I move this over to this side, it's as simple as the fact that T2x is just equal and opposite T1x, but their magnitudes are the same. See how now I'm looking at their magnitudes and they're the exact same. They're going to be the Let's take these T2x's and T1x's and let's plug in their trigonometrical, their trig values. I'm not even going to try with that this morning. So T2 cos 37, and this one's going to be T1 cos 45. Now, what the key of doing this part was, is that now I can solve, or I can isolate for just T2. So let's do that. Let's divide by cos 37 on both sides. I'll get T2 equals T1 cos of 45 degrees divided by cos of 37 degrees. Now, here is what I was talking about, where we have now hit a dead end. We don't know what T1 is and we don't know what T2 is. Let's pump the brakes here and let's go take a look at the y direction and see if we can figure something out. So the y direction is very similar setup. F net y equals 0. We've got T1y plus T2y, just like in the x direction, but also in this case, we also have FG. All of those are added together to equal 0. Now, let's get rid of our vector arrows here. Let's do the same thing again. You can do this at different points if you want to. Let's move this to the right-hand side first. So we get T1y plus, just like we did in the last question, T1y plus T2y equals negative FG. And now let's replace our values where we can, okay? So T1y is in the positive direction, so that can just stay T1y plus T2y, also in the positive direction, and negative M, which is 30. You know what? Let's just write in MG here. Okay. Let's keep our vector arrows for one more step here, because now we're going to plug in our values. So T1y is technically just T1 sine 45, but it's positive. It's in the positive direction. So T1 sine 45 degrees plus T2y, which is T2 sine of 37 degrees, is equal to negative M, which way up here is 30, times, now we plug in our g, which is downward, so it's negative 9.8, and here's that all-important cancellation that happens here. We have two negatives, so this is going to end up being a positive. And here is where I'm starting to realize, I'm starting to see that, okay, I'm having the same scenario here where I have a T1, I have a T2, but I can't solve for either of them. I have two unknowns. But here is the key. Here's what we can do to solve this problem. It's very tricky, kind of a creative way to solving the problem. We take what T2 is equal to here, and we have done substitutions before, but maybe just never with something that looked quite like this. And we plug it in for what T2 is equal to here. And what that's going to do for us, I'll show you what that's going to do for us. Let's write this out again. T1 sine of 45 degrees plus, now we plug in this entire value for what T2 is actually equal to. Because remember, T2 is just this, right? It's not like we have T2x or T2y that are different anymore. We've gotten rid of our y's and our x's, replaced them with our trig values. So now we have an actual answer for T2. So T1 cos of 45 degrees divided by cos of 37 degrees multiplied by sine of 37 degrees. And let's just plug into our calculator what 30 times 9.8, 294. Okay. Now what I want you to do, this part, now this looks really confusing, but it's actually not that confusing when you realize that sine 45, cos 37, sine 37, they're all just numbers. If you take a calculator and you plug in sine of 45, you're just going to get 0.707. Well, let's just plug those in right now. T times 0.707, that's T1. Let's do this one now. So cos of 45 divided by cos of 37. Don't forget this one, times sine of 37 will give us 0.53, we'll round up to 533. So that's now T1 times 0.533 equal to 294. Now this is the exact same scenario as if I had 2T1 plus 3T1. Well, that's just going to be 5T1, right? Because you take the 2 plus the 3. So all we have to do here is take 0.707 T1 plus 0.533 T1. Well, you can just add these up because the symbol is the same. We're measuring the same thing. So 0.707 plus 0.533 gives us 1.24. So this is technically T1 times 1.24 equals 294. Now, after all that, we have something that we can solve, right? We can find T1 now. T1, I just divide by 1.24 on both sides. If I do 294 divided by 1.24, I get that T1 is equal to 237 newtons. So there we go. We did it. We got T1. After all of that, we've got T1. Now, how do I find T2? We have to find T2. Well, here's the trick. Is you take this T1 value now and you come and you avoid all that and you plug it in right there now, right? Because now you have a formula that you can solve for T2 if you know T1. So that's the tricky part there. It's like a double substitution. So 237 times cos of 45 degrees divided by cos of 37 degrees. And if you plug all of that into your calculator, you should get 210 newtons. And that is your final answer for T2. And you are finished. So that's a tougher question, But as long as we just start and we, take it step by step, all the steps themselves are doable. So give them a shot on your own. And if you have any questions, just let me know.